Hi, my name is Łukasz Langa,
And my name is Pablo Galindo.
and this is the Core.py podcast, an established podcast where we discuss internals of CPython and our adventures in making a new version of your favorite programming language. This is our 17th episode, and it's a fun coincidence. We wanted to talk to Savannah Ostrowski for a while about her contributions to Argparse and the JIT. We scheduled an interview, and then Brand Booker, Justin, nominated Savannah for the commit bit. So now we are recording an interview with the newest member of the core team.
Yeah, nice. Congratulations.
Thank you.
Right. Congratulations on joining the team. And, we always have to be thankful for people who spend their time to contribute to Python. So thank you for that. Thank you for signing up for this janitorial job of doing this now forever.
Exactly.
Once the commit bit is assigned, it is never removed. That's the rules. That's the rules.
I told Brant, I was like, nope, I'm done now. Thanks for the commitment. I'm walking away.
No, it's too late. You should have received your a compulsory change to the project. Now you're chained to the project for alternative.
Right. So how did it all start? What brings you here? What made the story begin that ends with you getting the commit bit?
Well, a dark January day in the year 1990. No, I'm not going to start back there. But I don't know. Where do you want me to start?
It's just why you started to contribute to CPython, right? This is a very popular question. One of the most of our listeners actually ask this all the time, how people started to contribute, because they are very interested on there is kind of a barrier for CPython contributing. It's just quite high. People don't know how to start. So just talk about your story, why you would like to, why you wanted to start contributing to Python, maybe who kind of nudged you into contributing, and how was your experience, that kind of thing.
Yeah, I'll give some background to how I even started writing Python. So I come from what might be a non-traditional kind of background. I was in a environmental studies undergraduate degree, and I went to school at a really engineering heavy school in Canada, and all my friends were making a lot of money during their internships writing code and doing engineering work, and I was working in government jobs where there wasn't a lot of momentum, but I was also doing geospatial stuff. And so I think it was a combination of people around me were getting their foot, doing engineering work, but then also Python was and is pretty popular in the Python community for scripting and stuff. And so started kind of teaching myself how to code, fast forward some time, end up getting some engineering jobs, and then get first job out of college was working at a drone startup writing Python to programmatically generate drone flight paths for reforesting.
Oh, so civilian drones.
That sounds very cool.
Yeah, so this was a startup. They're we're going to shoot seeds out of pneumatic tubes into the ground, and we're going to map it out and avoid clear-cut trees and stuff. And it was all done with Python and with Shapely. And so wrote some Python there, wrote some Python in a couple other jobs, and then eventually switched kind of career paths away from doing full-time engineering work into product management, and ended up getting a job at Microsoft doing Python dev tooling.
Yeah.
Okay.
And then there I was pretty active in the Python community, was doing Python for work, ended up meeting some of the core devs, Carol, through some channels. I think we also talked during that time,
yes,
Łukasz, about I think I interviewed you for something. I don't even know what I asked you about, to be honest, anymore.
Can I be in a podcast in the future?
Yeah. Anyway, so then, I don't know, Carol approached me at PyCon US 2023 and was like, do you have interest in doing this thing? And I was like, yes, but I have no idea where to start. I have no idea how to approach that problem. And I to your point about it being kind of intimidating, I think that contributing to open source is intimidating. I think if you're an outsider, trying to, nudge your way into a really established and prolific project, regardless of what it is kind of overwhelming. And then compound that with the fact that CPython is programming language and compilers, and that is a very different part of computing than I ever really worked in professionally. And so so from there, I don't know, Carol brought this up, and then I kind of stewed on it for a couple months, and just like didn't really know where to start. And then she was in town in Seattle, and we had dinner, and I was like, oh yeah, like I do still want to do this thing. And she was like, oh, like, do you know any of the other core devs? And I was like, yeah, I know Brant. Sorry, I should probably say Justin. I don't know.
Justin, yeah. We do have
One of us,
we do
one
have
of
the
us.
thing.
Yeah.
Yeah.
And then she was like, you should go bother Brant. And at the time I was still at Microsoft. So I was like, hey, Brant, want to talk about CPython? And I think that's like kind of, I had like kind of some inroads through folks that I knew from like work adjacent things and like networking and stuff. But
Right.
But yeah, I think like that's kind of like how the seed, the idea of doing this got planted in my head. It's Carol's fault, maybe.
I mean, to some extent, I assume that Carol was like nudging you towards contributing, but I suppose that precisely because I mean you were mentioning like this, or you were confirming this, that it was like kind of a daunting thing to do. So I suppose that you had already some interest on doing so.
Yeah.
What was driving you towards the thing?
Yeah,
Right? Like,
I mean, I think like even though I had switched jobs like away from being an engineer full time, like I've always really like been interested in contributing to open source, and like Python is sort of near and dear to my heart because it was my first programming language, and because like my first product job when I switched to Microsoft was like very like I was working on Pylance, which, kind of extends the Pyrite type checker. And so like, that's sort of like deeper into the ecosystem and like kind of got a lot of like exposure through that. And I was like, oh, it'd be really cool to like contribute to CPython and then like the grow up from that was like, or author a PEP or like, or right. Like a million ors after that. But just like, didn't really know what to start, like how to start.
Yeah.
So do you remember your first PR?
Yeah, it was it was a debugging thing, or like no, it was like a jump instruction thing or something. I have to pull it up.
That was your first PR.
Yeah, well, so what happened was like I was like, Brant, I don't know where to start, and Brant was like, what are you interested in? I was like, it's too early for me to know what I'm interested in. Like I still sort of feel like that, to be honest. Like I think there, like the cool part about this project is there's like a million different things that you could go work on, right? And so like I was very adamant of not trying to like try and specialize in anything right away.
Oh, that's so interesting actually. Like one of the things it happens quite a lot, I mean statistically speaking at least, is that contributors that have mentors tend to like obviously work on the area the mentor normally works on, and then when they become core developers they kind of stick around just because they are comfortable around that, and like normally what happens is that it's all a ruse, so the mentor just wants to like drop from the area, so it's like no, it's your problem. no, I'm just joking, but like it's interesting because for what you are saying right now, correct me if I'm wrong, but like it looks like you're still kind of like interested to see what's in store, and like so you don't want to get married to Savannah as the JIT, right? Or
I think,
or I'm reading that wrong.
I think there's like some areas now where I'm like, no, like I want to like continue to work on a specific area. Like the JIT is definitely one of them, for like a couple reasons. Like I think what's also very cool about this project is like you can write C code, or you can write Python code, or you can like choose something purely because it's like an academic interest. Like I think that's more of like the JIT for me, or like try and be more pragmatic and like fix bugs and like work on more legacy parts of the code base. So it's like some new and some old. So I think at this point, like I kind of have like some vested interest in particular areas, but like I just think that there's too much to learn. And I feel like that's the reason why I always come back to like wanting to do engineering work, is that like I just like learning. And so like it's just like kind of an excuse to like constantly have something new to learn. Like a couple weeks back I was like, I want to learn more about like async code and like generators.
Cool.
Well, you can be years there. I mean,
I'm psychologically damaged from looking at that. Like I feel like
I mean, it's not even a joke. Like just for reference, like we are contributing. You follow the podcast, and we have been talking about this in other episodes. But like Łukasz, me, and Yuri have been contributing to this big PR adding like profiling to async and whatnot, and we are still to this day like we need to read big chunks of the code base to like how does this work. Like so it's never ending learning.
Yeah, I'm debugging something right now. I've been looking at it for like a week, and I've never looked at this part of the code base before, but it's a frame is not being properly unlinked when a generator is exhausted. And so I'm like trying to understand like the chain of events that's happening and the calls that are happening. And I'm like, oh, it's this thing. And then I go and try something. It's like, no, that didn't change anything. And then it's like, I don't know. It's just like going down this rabbit hole. And so I'm at this point, I'm like invested in trying to understand. I've spent much time on it that I feel like I have to see it through now, because now it's going to bother me for the rest of my life.
Oh, I know those.
Right.
I know those.
Well, don't worry, because in 2 months, our good friend Mark Shannon will change it yet again, and all your knowledge will be outdated. Like, it's not a joke. Like, frames has changed so much in the last 2 releases. Like, I remember I spent with Brand like 2 days or 3 days, like finding some frame and linking back as well, like it was affecting Python, and then like all that code is mostly gone, or at least different. Like the way we tell if a frame is owned by the stack or whatnot, which Łukasz knows because like a spoiler for later maybe. Spoiler, but yeah, like that's the other thing. Like it keeps changing, so like you like learning, you're going to keep learning all the time.
Yeah, not to point fingers, but I did bisect back to the commit and the PR this started in, and then bisected all the commits inside that PR, and it did start with Mark. So I'm just
right.
But
don't worry, you know the best feeling that will happen. Like this is it will happen eventually, and remember these words because you're going to be magical. You will at some point like someone will open a bag in some weird place, like totally like different from anything. Like parsing these upstream like segfaults, right? And then you are like, everybody's on vacation, so I will fix it, and you will bisect, and it will be you. so
I think that's like a badge of honor, though.
Yes. This happens to me all the time, and I was remembering like it sounds like a joke because like it's so cliche, right? It's so cliche that like who is the idiot who did this? It was me all along.
Yeah.
So yeah, it will happen. It will happen.
Yeah, but you said that your academic background is somewhat atypical. Like you mentioned, environmental studies, geospatial interest, and so on. I've heard that you did work for a company that makes one of those big apps for mapping that have a lot of users. Do you have any stories about that time in your life? That was pre-Python, I guess.
It was actually, so yeah, I worked at a company where I'm not supposed to say the name of the company, but it's the app that like would drive people off the road into like a lake. So if you remember that, you know. If you know, you know. But yeah, I worked there as like a vendor, and I was doing Python, but it was like mainly like Flask and like Apache Airflow stuff to like build DAGs, because I was working on basically like a data ingestion pipeline for consuming like open source map data into this app.
I see.
And so I did like some Python there. I also did a lot of, this is dark times, but I did a lot of Java there, unfortunately.
For data science, for like pipeline processing?
Yeah.
Like Hadoop?
Yeah, some Hadoop, but also like there's this open source project called Atlas Checks, which is like geospatial geometry validation. So like, okay, like we have some geometry. How do you know that something's like a valid roundabout? Or like that like the direction of the road is like pointing the right way, because it's all like ingested from open source. So like, you never know if someone drew this segment in the wrong direction, which would mess up the entire map or something.
I see.
So I worked there. So like my first couple jobs in engineering were like adjacent to my undergraduate degree, which was in geomatics, which is a Canadian. I think it's like maybe Canadian and the Commonwealth countries call it this, but it's like most like geography, but like the like satellite imagery mapping with like a very smattering of computer science on top, like a very small.
So before you started, like cars would go into lakes after you were done. Like there were fewer cars.
I mean,
in
I
lakes.
wish I could take credit for that. I don't think I can, but we can go with that too if you want. I can.
Well, there is more car in more lakes.
No, that's like, I mean, my actual claim to fame, which is like not Python related at all, is that I was the engineer that built the Chipotle nutrition calculator.
Oh, okay. What?
Yeah, I guess like I don't know if Chipotle's in Europe.
I mean, in London.
Okay,
for sure.
well,
there's one big, like close to my office.
Back in like 20, I don't even know. I was like an intern, and they were like, "We need to rebuild this thing in React," so I built it.
Oh, nice!
Yeah,
Wow.
so that's a claim to fame moment.
I mean, I have to say that to this moment, my favorite like story is the drone thing. Like because like this is such a cool thing to do. Like, I suppose I don't know how was the actual job, but I'm making my own story in my head, which like is fantastic, right? And like everybody likes to learn like all these like A star algorithm and Dijkstra and whatnot, but like it's always like boring shit, like planes. And you were like actually moving drones around like trees. That's awesome.
But also these drones, like when people think drones are like, oh, this cute little drone with like a tiny. This is an 8-foot wide drone. This is like
it's like a colossus of a drone.
But it's not that glamorous because it would be like,
hey, I'm a drone.
I go write some code. I'm like, okay, we're going to avoid trees, go around this thing using satellite imagery, whatever. We'd load the software onto the drone, go to the field, and then try and fly it. And then also try and like get all the nozzle tips right. So it was like, I learned a lot about like the hardware software interface and like how slow it is to build things when you're testing with hardware, because you like literally have to drive an hour into like a forest. So
but that's awesome.
Yeah, it was crazy. Is it crazy?
So you had a lot of field trips.
Yeah, that started at like 4 a.m. that I would like drive into the middle of nowhere with like a 5-person team. This was like 5 persons.
Oh, so I know. So like initially you were just going to Chipotle, but the mapping app just took you to the middle of the forest. And that's how
Yeah. It all makes sense.
Underwater base, in the underwater base.
Tried to go to Chipotle, ended up in the forest.
That sounds like a very good LinkedIn line. Okay, but like going back to CPython, like now that like you have been experiencing a bunch of areas, so that you've been doing some JIT stuff, and like you have been working on Argparse, and I suppose you have also like looked around. Like, do you have any like what is the like most funky thing that you have learned so far? Like, so from before CPython, I suppose you knew like a bunch of like trivia, right? Like there is this weird thing, whatnot. But like now that you have seen the the belly of the beast or whatever, like what is the most funky shit that you say like, Jesus, do you live like these people? Like
I mean, so I think it's sort of interesting to ask that question because there's like various levels of like WTF, right? Like there's like, I say this with love and with kindness, right? Like
No, please go ahead.
But like with the JIT, it's like, it's academic. So I'm like trying to understand how this happened. Like Justin went into a hole and came out with a JIT compiler, right? And so like that's a thing that I'm trying to tease apart. And then the other thing is like, okay, then I go and look at the more like legacy and like parts of the code base that have existed for a lot longer. Like with the JIT, it's sort of interesting, right? Because it's like new and like we can break the world and like it's actually probably not that bad yet. Maybe hopefully sometime in the future there's some more consequences because it's enabled and like whatever for our builds. But like I think with like Argparse or even like the generator code I'm reading, I think it's like, I don't know, it's like the rabbit hole effect of like everything is like kind of this like it's just been built up over time. So like it's like accumulated new functionality. Specifically with Argparse, like there's a lot, I don't know, when I started looking at that code, I was like, it'll be fine. Like I've used Argparse a ton of times to build like CLI things. There's a lot in there that I'm just like, man, I don't know how to like reason about this, or it has like, I don't know, at what point does like a bug become a feature kind of vibe?
Right.
So that's sort of interesting. And then I think like the other kind of interesting dimension of like how, maybe this isn't like funky, but maybe just an observation is like, as I've started to kind of like work on like performance adjacent stuff, like with the JIT and like the faster CPython folks, like it's very interesting to me that like everything related to performance is an experiment. Like everything just like, we'll try, like when I worked on, trying to reduce JIT memory consumption and like figuring out like what threshold we should use for invalidating executors. And like, that was like all like trial and error, right? Like, it's like, oh, we try this thing and like, see if that yielded any results or like messed up all of our benchmarks or like, so I think there's like, I said, there's various levels of like WTF, but it's like, it's just like various levels of like complexity and like learning and like trying to understand like, how to weigh the pros and cons of like, oh, we should do this new thing versus like, oh, we should like think about backwards compatibility and like
Yeah, pretty cool. So let's mention like Argparse in particular for a while, because this piece is old enough where you're correct. Some bugs now are features, and it's tied by backwards compatibility sometimes to like ridiculous extents. So imagine there was no backwards compatibility concerns. You could do anything you wanted. So is there anything in particular that you would break and you would make a breaking change in Argparse that you feel like that should happen?
That's like a really hard question. Because right now my headspace is so much about like even aspirationally thinking about new features, I'm still like, if I was working in a vacuum, I might just like try and refactor the whole thing and like not be concerned about the fallout of that. Because a lot of it's like kind of gnarly to reason about. There's like a lot of oddities that, again, in my opinion, have become kind of sort of expected behavior. And so like, is the bug really a bug if people have like worked around it or adopted it and like relied on it for some reason? And then, you know, like I think Suri and I have been working a lot of back and forth on some of these issues where it's like, okay, we want to make a behavioral change, but like a lot of that back and forth ends up being like about the repercussions of making the behavioral change, or like discussion about whether or not we should backport something that we think is a bug but like might actually be prolific enough that like backporting it might be a very bad idea. So I think it's really hard for me to think about new features. I think right now like my goals for the module are really just to get it into like a well-maintained state where like we have I mean we're never going to get to like zero bugs, but like
Oh, really? Believe me, no.
I mean it's, you know, but as a completionist, open source is like the best hobby to have, right? Because there's always, because I want to get to that zero, but I'll never get there, right?
Well, I mean,
Is that good though? Like it's like psychologically you have to be ready for this. That this is
It's like a blessing and a curse, right?
I mean, in the sense that if you are worried that like, geez, man, like I'm going to run out of my hobby, so yeah, no,
Right,
like, it's not going to happen. but if you like that kind of like, you know, zero inbox kind of feeling, in that you are one of those people, forget about it. This guy over here, like, spent his first year of like, you know, developer in resident, think like, man, I'm going to make a difference. I'm going to make this number lower.
of open
And
PRs.
I'm like,
yeah,
what
like-
happened, Łukasz?
Yeah.
I will lower or not?
Yeah, like I had a few attempts of like actually just going for it and like reviewing as much as I could, like to make the number go lower. And I managed to like at the best week I had like review and merge or close like around 100 PRs, and that was killing yourself. But like I did that, and I was like, yes, like the number actually went down. And then I had some like vacation for a week or something, and I returned and the number was exactly back at where I started.
Oh God.
Yeah, it's like it's an unmovable force.
Yeah.
Yeah.
But no, I think if I at least can get it into it, like, I mean, the reason I started doing Argparse stuff was like, you know, I've been working on the JIT with Brant, Justin for a while, right? And like that, like a lot of the work there is like very collaborative, and like Brant would be like, I'm thinking about this thing, like, what do you think? And we'd talk about it and I'd start working on something. But I wanted something, one where I was writing Python code, more Python code, and one where like I felt like I could be more like self-sustaining and just like kind of like have my own backlog of things to work through. And so like getting to the point where, I don't know, like I found like we had like a, you know, a list of Argparse issues, and I was like, man, like some of these are so low hanging fruit. There's like both stuff that we can close, things that are like, you know, doc updates. So I kind of just ramped up that way. And so like I have like made a dent in it, but I think like once I feel like we can get it to a state where like at least there's like active maintenance on it, then I can start kind of humoring the idea of a new feature. But you did kind of mention a new feature that I added to Argparse for 3.14. I think it was last episode.
Yeah, it was super popular. Like,
yes.
like yeah, like one of the, like, normally when I release episodes, there is a bunch of people that reach out, and a lot of people, like an untrivial amount of people, were mentioning that particular feature.
Oh yay.
So yeah, that was awesome.
Cool. That's awesome. Yeah, I mean, I think with that one it was cool because it's also like off by default, so it's like not liable to break anyone, but you can totally go ahead and use it if you want to. So that's always nice.
So talking, like, going back to the JIT, like you know, that's an interesting one because like normally, like anything related to compilers and like interpreters and parsers in general, like you mentioned academic plenty of times. I think that describes it very well. But like for a lot of people, especially maybe the ones that have not like a lot of computer science background and have not make actually like, you know, subjects in university or whatever, like they tend to think about these things like these unknowable things that, you know, like only magicians touch. So can you kind of talk a bit about like how was your experience like working with the JIT, like you know, the classic what looks hard but is really easy, or maybe what is easy but is actually like really difficult, because like that kind of thing like shows a bit like the reality of working with these things and like what it is to really like hack on them, or what was your approach to like learn them?
Yeah. Yeah, I think that, like, for me, like, I come from, like, I've done a lot of, like, web development. I've done some data engineering. I've done quite a bit of stuff in, like, the container and DevOps space. So, like, the parts of the thing, like, I think everyone's perspective on, like, this kind of a topic would be different based on what their background looks like. Like, for me, like, the stuff around, like, our build and, like, our CI pipelines and stuff, like, that I feel like was an area where I had a lot of experience that was transferable and was probably, like, easier for me. And, like, I honestly just really like that kind of work. I think that, like, the harder parts for me personally were, like, understanding, like, how the JIT intersects with the rest of the code base. So, like, because it quickly turns into, like, okay, so, like, you understand some of the JIT, but then you need to understand some of, like, this adaptive specializing interpreter. And then you need to, like, understand how, like, instructions work. And, like, if you're not from, like, a programming language type background, then that forming that mental model, I think, takes time. I think there's also, like, I don't know, other components that intersect with the JIT. Like, we use LLVM as, like, a build time dependency. And there's, like, work that I've been working on there that's been, like, I need to, like, go and, I don't know, understand a new compiler option that's, you know, in LLVM. And so, like, I don't really have that educational background. And so, like, that's taken me some time to kind of ramp up on it. And, like, honestly, but I still feel like I have, like, a ton to learn there. But yeah, I think it kind of just depends on.
So in this area, like, maybe even not only centered on the JIT, but maybe expanding also to the other things that you mentioned, like the adaptive interpreter, like bytecode or whatever. Like, what was the thing that so far you enjoy more learning? Like, that gives you more joy to learn? Like, geez, now I understand how, I don't know, instruction work. That was really super satisfying. Or, like, you know, I now understand, like, I don't know, preserve num. What is that in LLVM or whatever? Like, so what was the thing that was, you know, it give you more happiness to learn?
I mean, I think that by, like, working on the JIT and kind of having that, like, kind of cascading effect and, like, starting out in this area that's, like, kind of like its own little pocket, it kind of forced me to learn about other parts of the code base and how Python works, like, at a kind of foundational level. So that's, like, been kind of cool. I think that, like, brings me joy. I think every time I, like, learn about something else or I read some new part of the code base, like, my mental model gets, like, less fuzzy, or I'm like, oh, that's how this thing works. And I think, like, those kinds of moments are, like, really fulfilling for me. You know, I think there's always going to be more, but I think it's been just really fun to kind of, like, stitch that together in my mind. And, like, honestly, having, I don't know, listening to folks like PyCon talks, or, like, you know, even having, like, you know, listening to Brant explain something in a different way for, like, the third time, and it finally just, like, oh, all of a sudden I understand now, you know?
Yeah.
That's pretty rewarding. It's a pretty good feeling.
Nice. There is also the evil mirror of that experience, which is, like, when you say, that's how this works. Disgusting.
It's disgusting, yes.
Yeah, but at least you can have, like, an informed opinion about the parts, you know?
Right, yeah.
Now, speaking of which, when we first met, like, as you said, you were working at Microsoft on Pylance, and a lot of that, and I think our conversation was about type checking and some stuff around that. So as a Python user, are you actually a user of type annotations? I don't know if you already noticed this, but in the core team, this particular project space is just as divisive as it is in the general community. You're going to have people who are really, like, supporters of it, they use it, and you're going to have people who believe that this is the worst thing that ever happened to Python. So
I think it depends on how lazy I am. You know, like, I think if I'm, like, I don't know, I could play, like, politician here and say I think it's, like, kind of beautiful that you don't have to do it if you don't want to do it, right? Like, you know, it's like optional. And but that said, like, I think that there's a lot of, like, good stuff that's happened as a result of type annotations, and, like, I think that they can be a really great and informative addition to a good developer experience. And obviously, like, parts of the Python community have leaned into that, like, quite heavily.
I do have a horse in this race, and you know this, right? But you can be honest. It's a safe space. You can be honest about your experience with type annotations.
I think it depends on the complexity of the type annotation.
Yeah.
Right? Like, I think there are, like, ones that are...
Oh, this is an it depends answer.
Yeah. I mean, that's engineering, though, Pablo.
Yeah, but, like, do you know what is more fun? Like opinionated engineering. That's funnier.
Okay. I don't know. Again, it just depends on how lazy I'm being. If I'm trying to, like, script something for myself, I'm not adding type annotations. Like,
sure. So let me ask a very loaded question then.
Oh my god.
right? It is obviously being asked in mostly good faith.
In mostly
Like,
good
in-
faith.
The listeners cannot see the facial expressions that are happening right now, but I feel threatened.
No. Like, so imagine the Argparse source code was type annotated. Would that help you learning how it works, or would that make it worse?
Oof, what a 4D chess movement.
I mean-
4D chess movement.
I think that in like a well-established code base, that type annotations are really valuable. I will say that. I will leave it at that.
You have heard it here. Savannah thinks we should add type annotations to Argparse. The newest core developer is done. Official.
There are bigger fish for us to fry right now. Maybe type annotations would help. I don't know. I think that
Well, technically, you have type annotations in the JIT. Different kind of type annotations. But
yeah. But I just think like when I look at type annotations for like really complex types, I just get annoyed because I'm like, I have to figure out
what is a really complex
I don't know,
type?
like some data frame stuff, or I don't know, right?
Do you want me to break your heart? And Łukasz is going to disagree so much on this, but like, just do the following exercise. Go to typeshed and look at the type annotation from the function max.
Oh my god.
The function max. I mean, if you do it live, it's going to be fantastic. Just do it.
Yeah, but you can already expect that if there's a function where you
Nah,
can
it's-
put anything.
No, the Łukasz, don't spoil it.
What?
Exactly. Just look at it.
Oh my god. Well,
Well,
so for me, like when I was working on Pylance, like one of the big things we were trying to figure out how to make work was like we were using Pyrite, right? And so Pyrite gives like a lot of the static analysis and all of like the goodies from Pylance come from Pyrite. And so by proxy in the function signatures and in the doc strings, you'll see all of the types for all of the arguments.
Right.
Now imagine you're doing that for some like pandas function, and the function takes in like 25 things plus all the type, like trying to format that. So anyway,
Yeah,
It's just-
that's a good point. I in this case I'm very much with Łukasz like perspective, which is that is hinting to a bug. Like not a bug obviously in the code, but like that is like the problem there is because like you should have refactored your interface. Like if your interface is unreadable when you need to like look at the type annotation is because your interface is badly designed.
Mhm.
Like like imagine in C, right? Like if your interface takes like 15 parameters,
Yeah.
like it doesn't matter. Like in a compiled language, you will like that will look equally the same.
yeah.
And I will even argue, like for instance, I do a lot of C++ or Rust, and when you have a function that is more than 6 parameters, and then you have some templatized or generics there, and then it's like, like like the spans on these like many braces, it's just
Yeah.
unreadable the same way. So I understand why people complain about it in Python, but it's really the same. Like it's just a problem of like the interface being badly designed.
And to be clear, I don't even disagree that like if you have a type annotation that is like 5 lines long and like it's unreadable, sure. There are some ways in which you can structure this like, with type aliases and whatever to make it less annoying. But yeah, fundamentally, some types are just complex. But my real reason why I asked you this question was that like I see you as an ally. Like really.
He's trying to recruit you. He's
So Pablo doesn't know this because all features that he adds, like, he works on like the popular features. Like in my stuff is like always, for whatever reason, is super divisive, right? But Savannah is one of those people who will add black formatting to
I did
the
do
Python
that.
project.
Yeah.
And the one of your PRs actually did add black to CPython in one particular place. But that's how we do it.
Baby steps.
One module at a time. One module at a time.
I'm so much offended. Man, what is this? What is this? Man, the entire PEG parser is black formatted. Like, what do you mean? Like this has not happened yet. Man, what is this?
No. I'm not saying that was the first time that happened, but I'm saying I recognize an ally when I see one.
Because
So-
I'm not an ally. Well, you're right. I'm not. Like I'm just this chaotic person of
somebody
nature.
sounds really jealous.
No,
Like,
actually,
what is going
no.
on?
You tell me who added the first annotation to CPython. Who did?
I think it was Victor actually.
Well, okay, but that was
in
but
regular
that was rogue Victor.
Rogue.
Just type annotating random shit. Indeed. Yes, okay. It was Victor, but it was not on purpose. He was like, whatever, man, I'm just having type annotations to this function.
Yeah, because it was in regular regression testing. Yeah.
That's right. Yeah, so whatever. But like this was on the entire peg parser. Like the entire peg parser was like, okay.
Nice.
Okay, let me rephrase. Who added MyPy checking for the first time in CPython? It was me.
You know, a person can have more than one ally at a time, right?
No,
That's
I'm
fine.
not an ally. Don't. What is this shit? Like, what is that? What did you do?
But you didn't even do the two for the balloons. There were balloons, folks. I don't know what that was.
So you don't know this, but we live in a place with two dimensions because we have audio, but we also have video because like it will be a bit weird to be these disembodied voices, right?
We see
and
each other.
Łukasz Langer here, just meanwhile we were having this nice conversation full of like introspection and whatnot. He triggered this bullshit Apple effect in which like a bunch of like balloons appears on the video, and you can trigger that with your hands or some shit. Like if you do like a heart, like sometimes like it does the thing, but like
I think I have it turned off.
yeah, but he didn't do it, which means that he had to click on like he had to click on the Jesus fucking Christ. He had to click on the thing and then he had to click on reaction and trigger the stupid balloon. So just to distract us from the truth.
The timing was incredible.
Yeah, in any case, you gave a really political answer. And I'm not entirely sure which way it actually went because we got really distracted with like jealous Pablo.
I said type annotations are good. I just get annoyed when the type's really complicated and I can't figure them out. This is a me problem. This is a skill issue. It's a skill issue.
No, that's the political thing. Like the less political thing, I wanted to hear like, are we adding annotations to Argparse or not?
Łukasz, we want people to come back to the podcast, you know. You cannot just.
No, they will because this is going to be episode 2. Is going to be a
This is
cliffhanger.
cyberbullying.
Oh, okay.
I'm being cyberbullied right now.
Ooh.
Oh.
Aren't you on the code of conduct team?
I am, in fact.
Whoa, shots fired. Łukasz, it's time to move on.
All right.
No.
I take that back then. I take that back. We will discuss this on the issue tracker and even better on discourse. Well, the discussion will never end.
But
Weigh in, folks.
But you can always interrupt the discussion with the balloons. Well,
Now, if I could do that on discourse, I would.
okay, so let's move to a totally non-controversial topic. So, what is your favorite pep?
Savannah fainted.
You can see your own. You can see your own.
No, yeah, well, I was gonna say, writing or authoring a PEP was like a goal of mine when I started contributing. I was like, maybe someday I'll get to do it. And then I don't know if this is like a nice thing or a not nice thing, but Brent was like, we need to do revisions on the JIT PEP. Do you want them? And I was like, yes. So I did some revisions to that, to PEP 744. So that's kind of my favorite. It's like I guess I'm picking a favorite child, but I think that's my answer.
Well, you may end writing another JIT pep.
Well,
I'm foreshadowing the future.
I mean, yeah. We haven't. It's informational right now. So.
Informational. The best kind of pep.
Yeah. So
So what is your last favorite pep?
easily 484.
Oh,
Pow!
Łukasz was hexed. He was not prepared.
How do I make an Apple reaction of a broken heart? How do you do this? I don't know. What gesture do I have to show?
Okay. But I'm satisfied with this answer.
Okay.
I'm really
I just felt like it was like, I don't know, it was like an eye for an eye. You know what I mean?
To be honest, okay. I will tell you something. I think Łukasz knows this, but like, yeah, he knows. So I'm not against the pep itself, obviously, but I'm very much against that piece of code because as a parser person, I don't know if you have already had the joy of looking at how this works, but like the stringify annotations like fix is basically an unparse mechanism. So the way this works is that you write that annotation, the parser takes this like hard work to try to make sense of the semantics and all the bullshit, and like when it constructs this beautiful tree that represents reality, then this other piece of code comes in and says, well, it will be a pity if someone transforms this tree again into a string. So it's like, why? So there is this code that just recurses down the fucking tree that the parser creates with all this effort and memory allocations and shit. And it just got and transforms it back into a string. And it's really painful because it cannot do that because there is not enough information to do it properly. So for instance, if you type 3 spaces between 3 plus 4, it will not respect that. It will go back. And you say, well, that kind of doesn't matter because, like whatever. But you know what? There is other places when those changes are semantic. For instance, if you have a walrus operator, then there is places when you cannot have just the walrus operator. So the whole fucking code needs to add like these parentheses around everything. So the Argparse code is this parentheses in all places. So I just hate that because like from the parser point of view, it's really disgusting.
But tell us how you really feel. Tell us how you really feel, Pablo.
Well, I feel like I don't want to maintain that. Indeed, I actually made this change in which I ripped that out, and I did like this thing when the parser just grabs the string and says like, "Here it is the string." But that broke something. So I never. Yeah, I don't know. Some spatial bullshit. But so. And what was I don't know. But I think something broke there. But I never pursued it. But maybe I will now. Maybe I will. Maybe I feel now encouraged by more people hating type annotations.
But when I was trying to push like type annotations in Argparse, like Savannah said like, "Hey, we have bigger fish to fry," and that's probably right? I mean, there are bigger fish to fry, so it's in core Python is essentially choose your own adventure. You decide what you want to work on.
Well, my adventure now is to remove the type annotation and parser code.
You keep talking about the annotations, and I actually wanted to just already move on and just say like, hey man, like if there
but
are
I'm not
bigger
talking about
fish
parsers.
to fry,
I need to. Once I stop talking about parsers, there is no end to that. So okay. I will move on.
That's not a great parser that doesn't have a termination. Like like you have to terminate.
You know that you cannot know if the parser will finish. Like the whole is the halting problem. Is the halting problem. Like if a parser will parse the string in infinite time, is the halting problem. It's an unknowable problem. Like you cannot know infinite time. Wow.
Yeah, and it's even better with the peg parser, right? Like you cannot know if something is invalid.
Well, yes, you can run the parser. That's the whole point of the parser.
Yeah, you need to run the parser.
But you cannot. I mean, you cannot know him like previous. I mean, obviously you can know.
Looking at the grammar.
Yes, I mean you can say, well, I mean, I can know that 1 + 1 is valid, right? But you are parsing it, so it's just in your head. It's a biological parser. You cannot prove that it's valid. Like so, yes, very good.
But anyway, choose your own adventure. Savannah, what is your big adventure? What are your big plans related to whatever you are working on? The big fish that you mentioned.
Well, I think that the next like big thing is probably working on trying to like host the JIT stencils and in support of trying to get the JIT to be part of the build but off by default for 3.14.
Yeah.
So that's something that we talked about at the core dev sprint in September. And I think there's like a bunch of work there around like actually producing like reproducible stencils and like actually removing hard-coded stuff out of them. And then also, I think that like trying to figure out what the developer experience for that looks like and like for people that are working on CPython long term. So yeah, I think that's like the next kind of big thing.
So wait, so if somebody's not a core dev here and they're hearing JIT stencils, it sounds awesome, but like what even is that?
I mean, yeah, it's like a template for a piece of code fragment from the bytecode stream. It burns in some information, it does some stuff, right? Like, I don't know.
Normally you will have in Python, you will have like an instruction. For instance, let's say you want to add 2 numbers. So there's an instruction called like a binary add.
So the way I thought about this and the way somebody who is like, commuting to work and listening to a podcast before their first coffee. Like,
well, but it's a complicated topic.
The thing that they just need to know is that our JIT is copy and patch. And that's the template that we're copying and later patching. That's
I think I mentioned copy and patch, but I didn't describe it because I don't remember what Brant went into.
Man, what you want is one of these like mad scientist explanations, like a balloon that is too big and then you poke it and it explodes. But like you cannot do that. Like it's hard.
Because the thing is the stencils are already those bundles of binaries, but like this is binary and like it is C code on like the way we look at it because it's just a bunch of like I don't know numerals in a .h file, but like in the end this is already binary code that we're importing.
Isn't that misleading? Because like let me ask you a question. Like let's share our understanding of this. Why is that better? Because like think about it. Binary add that is written in C, and the compiler will grab that code and it will eventually compile it into machine code. Like it will be like machine instructions. So why having a template that has mostly the same code just compiling into machine instructions later is different? You know what I mean? Like it's just it's machine instructions at the same in the same level.
Yeah, right. Yeah, because this is not binary add, right? Like this is something that like is more granular. Like you're skipping the checks and everything, right? Like this is where the sort of like specialization of the JIT like comes in, because now it is not that much different, which is why it's not faster, right? Like but like in the future it can be faster by just running less things, by having less non-checks and stuff like that, and like skipping overflow checks when you know it's not going to overflow and whatever, and like having all those sort of optimizations on, oh, this is, I don't know, embarrassing parallelizable, so you can just put something on the thread or whatever. Like there's a bunch of things that you can do like now, like with copy and patch, but like that's sort of by observing the how the data flows through it, because binary add is everything, right? Binary add has all those ifs and elses, and this is what you have.
Those if and alphas like will need to still be there.
Yeah, but there's going to be less of those.
Like you cannot just say like, you know, I'm not going to check if the number that you gave me is still an integer. You need to keep checking. It's just that is that you have more power to reorder.
Yes,
right. Like
exactly.
it's just as you learn more things, you have.
Mhm.
It's like it's not all about the JIT really, right? Like that's an interesting insight maybe. So it's not about like, oh, I have this slow Python code and then I will combine and have machine instructions, because you already have machine instructions. It's more about like I have these little pieces that are machine instructions that now I can reorder and remove. So as I learn more about what the program is really doing, I can say this is useless. So I'm going to
or like burn stuff into them, right? Like
exactly, or like change it slightly, or like, you know, change the call to by number add to something different. But it's not that, oh, now I have instructions, because like when people think about decompilers, they think about like, oh, you have this interpreted code that now is like, you know, assembly. But no, you already have assembly. It's more that I can now reorder my assembly and like change it slightly.
I mean, you could. There's also like a 2-sentence description of copy and patch on Wikipedia that I think does a pretty good job, maybe, but it still requires you to like understand how like it mentions like ASTs and stuff. So like I don't know if that's really approachable.
No, like people are lost even before that.
I mean, yeah, it's like a template for a piece of code fragment from the bytecode stream. It burns in some information. It does some stuff, right? Like I don't know.
just to have some laugh, I asked Claude to summarize copy and patch JIT compiling in 2 or 3 sentences.
Okay.
It says, imagine a compiler that's like a lazy college student who copies their friend's homework, but only the parts that are actually good. This copy and patch. That's copy and paste JIT compilation and nutshell. Instead of doing all the hard work of compiling everything up front, it waits until code is actually used and frantically copies the relevant machine code chunks from a template and patches them together like a last-minute programming quilt, adjusting addresses and constants as needed.
Frantically,
yeah.
That's like anthropomorphizing, like.
But it's also incorrect. Like it's,
You know?
I just love every AI thing starting with imagine. Imagine.
Yeah, what do you know about imagination, Claude? Right, so talking about stencils, at the core sprint, we were discussing what to do with them such that people can build Python with a JIT without needing to have LLVM installed. We are also thinking about versioning them. Where do we stand on this? What's the plan there?
I think the plan right now is to just generate them for the platforms we support and then just pop them into the repo for now. I think there's a lot of different approaches there. I think actually, I need to go bother Justin again because he keeps telling me he's going to post on Discourse, but then doesn't, about trying to like socialize the plan. But I think we need to figure out like longer term what that will look like. And then I think most people didn't really have any reservations about the set of stencils we'd be producing.
Yeah, makes sense to me.
Yeah.
So that's the biggest plan, because what that will allow us to do is to build Python with a JIT without actually having all of this LLVM infrastructure on your local box.
Which is important, because let me tell you something, which may create sub-conversations here. But like now, what version of LLVM will require, Łukasz?
18.
19. You fail. She changed that last week, 2 weeks ago or something like that.
Yeah.
And you know what? 19 is especially annoying because you see, like, do you know how you get LLVM 19 on, for instance, Arch Linux?
Oh,
You compile LLVM.
Which takes forever.
There is no fancy script that you download with wget and then you say 19 and then you get a binary. No. You compile it. And you know how much time it takes to compile LLVM?
Well,
4 hours on a 32-core machine with 128
wait,
gigabytes of
what are
RAM.
you
If you
doing?
compile,
Why did it take that long?
if you compile with the back symbols, you compile entire LLVM. It's 4 hours.
With Ccache?
wow.
Well, I mean, Ccache only works if you have
Yeah,
compiled
I guess
before.
that's fair. That's fair.
So, and also, like, do you know what? Like, I was talking with Justin, and Justin confirmed this. I was not the first one suffering this. If you compile, because like this is what you do, like you say, okay, this is a big piece of code that I need to compile. So -J, which for the ones that don't know Makefile, that enables full parallelism. Yes. So, so it enables full parallelism. So it uses my 32 cores. But you know also what it uses? It uses all the RAM in my machine. And there is not enough RAM to compile all LLVM with all those 32 cores, because the more cores you have, the more fucking RAM it tries to use. And then the OM killer says, oh man, that's a lot of RAM. It will be a pity if I randomly kill one of those processes. You need to start from scratch. So yes, it's very painful.
I didn't know you held so much frustration in your heart towards me, Pablo.
Towards you?
Yeah, because I'm the one that brought this upon you. If you're trying to
no, but you don't understand. You don't understand. You think no. You don't understand. I actually you actually saved the day. You don't know that, right? You don't know that because you are not still aware of the self conversation that is happening behind the covers. But your change, bringing LLVM 19 to the project, actually shaped the whole thing. Because one of the things that the JIT is not doing, and is really hard to fix, is to make unwinding works, and that is important for profilers and debuggers and whatnot. Because right now the JIT breaks absolutely the hell out of everything.
Yes.
We were very close to lost faith, because like that shit was like so stupidly hard, and like it still is, and well, it still is very hard. But we just find out, like, you know, like news. We find out literally yesterday that LLVM 19 allows you to drop this stupid calling convention, the HSCC whatever bullshit, and allows you to do preserve none. And preserve none, if you compile with frame pointers, it makes unwinders work. Wow.
Cool.
So we can compile with frame pointers, and then some unwinders will work, which is more than 0. And taking into account that this is a limited 2-line change, that's great. There is only one problem that makes the JIT 2% slower, which for me is a bargain, because like fixing this thing outside, like otherwise it's just insane. Apart from that, making the JIT 30% slower or 40% slower. But so this is a really good deal, and it was only possible because you moved the thing to LLVM 19. You didn't even know about it.
and now we're using.
You see, I don't
preserve
hate you. You fixed it. You fixed everything.
Wow. I'm gonna, I don't know, write that down. So next time I get sad, I'm like, I just fixed Pablo's whole life, and that'll make me feel better.
Well, you will get dragged to this problem. Don't worry.
Again, it's never ending. It's never ending. So.
Well, this is a bit more hairy than others, but we can talk about that later. Yeah. But yes, you see, I don't hate you. Like, even if I need to compile everything from scratch, this is awesome. This is awesome. You know, I have answers for everything. We have a question from Mai. How is this possible?
How do you deal with trolls?
How do I deal?
That's what Mai wanted to know.
With trolls?
Yes.
Or with difficult conversations?
Well,
because like
that was the question. How do you deal with trolls?
Well, I mean, open source is open. Which means that there's always going to be like difficult people, and difficult has different flavors. I think the biggest thing is like trying to just assume best intent. Like, I think we work on like a very globally distributed team and project. And so I think there's sometimes where you're like, you read something, you're like, oh, that was like really terse, or like that person sounded super rude. And like, you don't really know like if English is their first language, or if they're using like, you know, translate tools to kind of like respond to things. So I think like trying to just ignore the tone, but try and like observe the behavior has been really helpful for me. Like, I think I don't know. Also, people just don't want to write a lot sometimes. So it ends up being kind of like maybe not the nicest thing you've ever seen written to someone. But I think the other thing is like, there's a lot of different like experience levels of folks contributing to the project. So I think like also like trying to be cognizant of that. Like, there are, I don't know, especially with Python, I think like, and I've like worked on other open source projects, but I think like with this one specifically, because it is like super publicly visible, there's like a lot of people that have a lot of interest in the project, either from like a contribution perspective or from like I want to weigh in on this thing. And they may not always have all the context. And so there's like an element of like patience required, I think, to like hear them out, but also like, you know, if you have the bandwidth, like educate them and try and like bring them along a little bit. But obviously if they're like super rude, I think it's just like, just walk away and just kind of like, I don't know. I think you kind of have to have thick skin. I don't know, like, obviously, like, I'm a woman, so I can't really speak for everyone, but in my experience, like, I think there's certainly been elements or times in my career where I think required to have thicker skin than, like, maybe some other folks. I think it kind of varies from person to person, probably.
This is actually a very timely discussion since there is a number of interactions that we have either on Discourse or on the issue tracker that get actually even seasoned core developers to just check out because they are just too terse. They're just too unpleasant and they just lead nowhere. And there's some pattern of behavior that doesn't quite meet the criteria for abuse, but it's just something that they don't feel like it's worth the pain. It's worth the abrasive nature of it. And I feel like I admire how you say like, oh, you just have to be a little thick-skinned, and it's great that you're able to deal with the worst that our community has to offer. But you would think that that shouldn't be a requirement, really, right? Like people should just be able to focus on the technical side without having to be like extra resilient psychologically. So what's your thought about that, going more into the direction of what Pablo asked with, which is how do you deal with hard conversations, especially online in text and so on?
There have definitely been times where I'm like, this seems like weird to me or like is really off-putting to me, and I like kind of want to check out of this conversation because I'm like, I don't think it's like I'm getting like I'm emotionally invested in this thing, and it's like putting me in a bad mood or it's like deterring me from wanting to contribute. And I think like, you know, trying to like have a sounding board of someone to like talk to about it, I think is like really important, especially like for folks that are like newer. And I think to your point, like it's sort of shitty, like if I'm, you know, if we see like someone who's super motivated as a contributor and doing like great work and then like they have bad interactions with, I don't know, some other person that's maybe not on the core team or other folks that are on the forums, and they're like, oh, Python isn't like super welcoming, or like I feel like I've had bad interactions enough that like I don't want to be part of this anymore. Like that's obviously something none of us really want to happen. But I do think it's like, as a moderator, I'm sure that's like really challenging to kind of understand hard, like what's that line? Like where does the line sit? And like it's definitely like case by case too.
Well, I mean, there is also other challenges. I mean, not unique to a specific like group, but like of being a core developer. Like for instance, one of the, I mean, there is the actual people that are having like some kind of like bad way to communicate or like some bad interaction. Is like but that's also like it's a challenging situation, but it's also kind of a more clear cut that, okay, there is a problem here. But like for instance, for me, one of the most, and I don't know how much you want to talk about that, so we can move on if you don't want to. But like one of the most challenging things for me is that precisely because this project is so big and it has like so many different repercussions if you change things. Most of the time, you are forced to
devil's advocate,
kind of have to adapt an opposing position in several like decisions, and the impact of those decisions can like are really big towards other people in the core team. So, for instance, sometimes someone is very passionate about adding some feature, but that feature is going to break something, or like maybe you want to fix something in a specific way, and like that way is going to be incompatible with something else that someone else is doing, or something like that, right?
Of course.
And even if there is nothing wrong with the person, like it forces you to be literally in the opposite realm of like a conversation where, like, you know, depending on what is decided, it will have consequences for everyone, and that is something that I still struggle quite a lot. Like I just never know how to navigate that really. Like, I mean, I don't think I do a bad job at it. It's just that I never liked it. So I don't know if you ever had to have yet any of these particular scenarios.
Not necessarily like in CPython, but I think like in other places in my career, that's definitely come up. I think like it's hard because like you want to I don't know, like hear them out and like understand. Like, I think the other thing is like when someone feels very strongly about like adding a new feature and like it's at odds with like the goals of the project or like some core tenet that we have, like I think people also will suggest like, I want this feature, but like what is like the actual, like the feature is not necessarily the problem we're trying to solve for, it's like the solution.
Yeah.
So I think like, I don't know, I try and like understand like the use case or the scenario or like the actual like thing they're trying to accomplish more than like the thing that they think is the right solution, because like again, like they might not have the context or the background to know that that's like the right way to implement it in the language, you know.
Right.
But yeah, I think it's hard also not to be like, I know better than you, so like don't care about your idea or something, you know. Like I think especially in online, like I mean we laugh, but like I think online is so hard because you miss like all of the like the body language and like the facial expressions that come along with like actually having a conversation with someone. And so it's just like, I don't know, a one-line sentence being like, no, we don't want to do this is like, feels so different like if we have no relationship at all, right?
I get it. Yes, which is why you need the Apple balloons and everything.
Right. Well, there is plenty of core developers that discussing with them in person is such a different experience than discussing with them online. Like,
This is why we do the core sprints in person. This is why the language summit is in person, because like things that sometimes take weeks of intense conflict online turns out can be solved by just people talking face to face. It's amazing because we assume that with Zoom and remote work now and post-COVID and everything, we can interact just fully being remote to one another. But it turns out that there's still some magic from actually being in the same room.
It's like the same reason why like, and I'm not like necessarily pro going back to the office, but I do think like I'm hybrid now for work, and I think that there's like that water cooler effect of like, oh, I bumped into Pablo and we talked about this idea that he had that like, I don't know, there maybe wouldn't have been a good forum. Like, of course there's like discourse, but like sometimes that just happens organically and it's like you had this idea that's like maybe not serious enough to want to write a whole post about it, but it's like, I don't know, it's hard to do that. I think it's hard to do that in like a purely online format.
right. I think also in person, like it forces you to see the immediate effect of what you say.
Yeah.
Like in the sense that, if you are like two-thirds, you can see immediately that something is going wrong and like you require more explanation or something like that. So like, it forces you to have the feelings of the other more present. Like online is very easy to just get driven, like that you're missing that particular component. So it's very easy to, feel very like anger because someone is like opposing you, and then you just put more anger. But like there is no actual communication of how people are feeling. It's just like, here's a packet of information and here's the packet back. Like you cannot see the immediate effect of your words there, and you cannot just adjust for it if you like adjusting, or you cannot. You may be thinking, oh, we are having just a passionate conversation, but on the other side, it's just fucking miserable. So that thing is more easy to see in person, I think.
Totally.
Assuming that everybody has good intent, obviously. Like obviously they don't have.
I have a random question. It's really random, but I just gotta ask. So I'm Polish, right? And your last name sounds Polish. So like, what's the story there? Do you still feel any connection to the old continent? Like, do you have family in Europe? Like, what's going on?
Well, so my dad is half Polish, and his father came over to Canada after World War II, and so that's like. And that's like the extent of how Polish I am. I don't speak Polish. We grew up eating Polish food every Sunday with my grandmother.
Yeah.
Potatoes.
Your question is actually hilarious though, because I'm actually going to Poland for the first time this coming week for work.
Oh wow.
Yeah, I'm going to Warsaw. I leave tomorrow. So.
Oh. Wait.
Fantastic.
Wait. What is this thing?
Yeah.
Are you prepared really to travel to Poland? Do you know how to say thank you in Polish?
First of all, I'm a travel baby. Okay, I'm trying right now. You're catching me. I'm doing this time shifting thing. I woke up this morning. I started working at 5 a.m. to try and like
for the jet lag.
get away from the jet. Anyway, and so I'm like, I'm gonna show up at like noon on Sunday, and I'm gonna be like, where am I? Where do I go eat? How do I get to my hotel? So yeah, I'm hoping that I can like beat jet lag enough. I can go like walk around the city a bit. There's like an office for Snowflake in Warsaw, so I'm visiting for work.
Nice.
And then the second half of the week I'm going to Berlin. So
But wait, I want you to try live here in front
God.
of us, how, because I fail at this. You need to understand. So I went with Łukasz to PyCon Poland, and he tried to only teach me the only thing, how to say thank you,
Okay.
and I miserably fail. Like to this day, I cannot actually say it correctly. So I want you to try, because I just want to see if I'm just stupid that I cannot pronounce it correctly, or like it is a common thing.
Jeez. Okay.
So Łukasz,
Hit me.
say thank you.
You just say, dziękuję.
Be so for real right now. Okay. Can you say it again?
Dziękuję.
Giancuno.
Oh wow,
Fantastic.
That is very close.
That is very good. That is very good for a first attempt.
Oh, I feel like I just said I don't. How do you spell that?
That will not help you. I will send you the spelling.
Well, that's
send
why
you
I'm
the spelling.
asking, because it's like probably got like a W next to a Z next to it.
No, I've been there. It's useless.
But if you learn that, you can use that tomorrow.
Yeah.
Okay.
You can use that
Okay.
tomorrow.
My attempt
So,
to
yeah.
this is I still cannot say it correctly. It's like yang kujang. Like nah, it's
Yeah,
not great.
you sort of move the syllables
Yeah,
around.
apparently
it
there is
starts
a-
with a J. It starts with dziękuję.
Dziękuję.
That's
Yes.
good.
So apparently there is an easy version of this. What was the easy version, Łukasz?
The
It's
easier
like-
version has just two syllables. Is dzięki.
Janky.
Okay, so so he told me this, right? I could have said to all the waiters that were like in the restaurant Genki, but instead of doing that, he all added then. But like people that don't pronounce the young like correctly, they sound a bit stupid. And then I said like I'm not going to the easy version, so I forced myself into the hard version, and I could never do it correctly, so I look even more stupid.
Jancuyo.
Yeah, very good. Yes.
I'm trying really hard. I'm gonna forget this.
I'm feeling really good and really bad at the same time. Jesus.
I can't speak
Dziękuję.
any Polish, so I'm getting married next year, and my fiance has a very American last name, and I'm thinking about taking his last name solely because I think it might be beautiful to have a name that people can spell and pronounce properly, but I
Alright.
recognize that would be abandoning my heritage, so I have to weigh that.
Well, congratulations on the marriage.
Thank you. Yeah, so we'll see.
You're free to choose your last name. I don't think it's abandoning your heritage in the sense that like you can still choose to visit Poland and say dziękuję, and it's still you, right?
Dziękuję.
It's
Yeah.
fine.
Right. Actually, as a last question for this segment, like, is there anything that you think we should have asked but we failed? We can fix it now. If you answer no, it will be legally binding, so you cannot complain later.
Oh my gosh. I don't know if I have like another question. I feel like I would just say, like, for people that are listening and they're like, oh my gosh, being a core dev would be so cool. I just like want to put it out there and say this for anyone who's like thinking about contributing or thinking that like being a core dev would be cool someday, is that you should just try. You should just like try and put yourself
Yeah.
out there. And like, I just
Yeah.
explicitly wanted to say that because I think for me, so much of like the difficulty of contributing wasn't the actual code part. It was like the confidence piece and like the willingness to like be wrong in public or like learn in public. And so I just like wanted to explicitly call that out. Just do it scared. Do it scared.
Do it scared.
Right.
That's wise.
You hear it here, dear listeners. Just try.
Yeah. Like, I don't know. I feel like for other projects, like I was contributing to poetry for a little bit. Like I started out there like writing tests. Like I would just like run like a test coverage and try and write tests for like various parts of the code base that were missing tests. And like that was a really good way for me to like learn about the code and also be like helpful without like needing to like figure out what issue to work on or like help with docs. Or like I added like a dev container configuration to their project or something. So I feel like, I don't know, I just wanted to explicitly say that like I recognize that it's scary. I was also kind of scared, but you should just do it anyway.
Awesome.
And on that positive note, let's move on to
PR of the week.
All right, let's give a minute to our guest to, recover from talking for an hour. And I'll talk for just a short bit. I did a weird thing now, contributing to a PR that Yuri and Pablo started that is about gathering and presenting asynchronous call graphs. They're not stacks because, in async programming, there can be graphs of things that await other things that await other things and so on. But the functionality there is essentially useful for everyone using asynchronous programming since you will be able to see what is actually waiting on whom and why, and including from outside of the process. And that bit was very weird to code for me. That bit was very surprising to sort of deal with, because what you're actually doing is you are looking inside some other process's memory. And if you're not really aware about this, this is legal to do in an operating system. If you are running Linux, then it is legal to look at other processes' memory if you are running under the same user.
Surprise question. What is the system called?
What is the system
To
called?
look into other process memory in Linux. You have been looking at
Oh,
that system
I didn't
call.
look at the...
No?
I didn't look... yeah, no.
Oh, it's process BM read B.
Okay, cool.
That's the Linux one. Or ptrace, but we don't use ptrace because bullshit. Process BM read
Yeah,
B.
but in any case, like, you can do this. And on macOS, you can also do this, but only when you're a super user. But like with sudo, you can make a process read other processes' memory, and that's fine. Only the world is weird now, because if you want to read some struct and you want to follow pointers there, you need to first read the struct where you have a pointer, and then you have to read where it points, and then you have to read that memory that it points to again. So just there's additional interaction that you need to deal with.
Whoops.
But the point of this is that in the end, you are going to get a call stack plus the graph of who awaits whom from outside of the process, which means you can debug your async IO applications without any magical support inside your process. It doesn't have to know that it's being debugged. It doesn't have to run anything that slows it down. So I'm very excited about this PR. It's still open. It's 12.46.40 because half of the core devs decided to like look on it and like opine on it.
Well, it's very exciting. So everyone wants
Which
to...
we're very, very happy that it got so many eyes. But yes, there's a lot of comments there and there's a lot of review. So there's still some changes. We're very happy to see Andrew Svetlov again, an async IO maintainer who was gone for a bit. And now, like, he's back. So yeah, very cool. We were making I'm making some changes that he wanted. And hopefully soon enough, the PR is going to be good enough for Kumar and Mark Shannon to approve. And we're going to be running with that. Because with that, you can have memory that's going to be better. You can have LLDB that has Python support that's going to be better. You can have asyncio REPL that is going to be able to tell you like what is happening in the background in a nice way. It's going to be amazing. The future is going to be amazing.
Yeah, it's going to be, and you can have profilers that can profile asyncio. Like Meta is going to be super happy as well because they really want their Instagram stuff to be profiled. So, very cool. Okay, so my PR of the week is actually not a PR yet, but like it will be soon, hopefully. But it's close. So I spent my whole vacation week, of two, just discussing with Brand basically how to make debuggers work with the JIT. And let me tell you something, that was painful. It's not because talking with Justin is painful, but because the whole topic is just stupidly complicated, like really complicated. Turns out that like there is plenty of interfaces to make like, unwinders be aware of auto-generated code. But first of all, there is too many of them, depending on the unwinder. So, for instance, if you want to have C++ exception work, that is what is called a native unwinder, which it can be either in GCC or LLVM, sorry. And that, it needs to register in one way. But like if you want to use libunwind, then it's a different way. And if you want to do it libunwind on Apple, it's a different way. And like everything is different. What is worse, most of these interfaces are only like used by people that do JIT compilers or the compilers themselves, which means that they are super undocumented, like extremely undocumented. Like you need to read the code. Like there's no other way around it. And like the whole thing is just bad. So I just spent like a lot of time doing these little prototypes of like creating a tiny JIT that was just like, a trampoline, and then trying to like make the unwinders work, the automatic registering work in different ways. So I could like show it to brands like, hey, look, this kind of works, so we can try to do this on the JIT. So we actually figured out how to make, C++ exception work and libunwind work, and we also make GNU backtrace work. But then we discovered that all of these things make the JIT 30% slower, which is not great. But that is when we discovered that out of the blue that combining the JIT with LLVM 19 and frame pointers make most of them wonders work on Linux at least. Which is great because, that it still makes 2% hit, but I think that's a bargain, personally speaking. But we need to discuss this.
Yeah, we'll see
a bit because it's still non-trivial, and the whole thing is so ridiculously complex. And but I'm excited because at least now we have options when before we have zero options. So yeah, that's great. And this is kind of, at least in my view, sort of required for the JIT. So it's pretty good that we have a way to solve it.
Yeah, that sounds really impressive. Well, let's hope that the review goes smoothly.
Yeah.
How about you, Savannah? Is there any PR that you would like to talk about that you were working on recently?
Well, it's not of this week, but it's probably like the most substantial thing that I worked on in the last couple weeks. And I think
that counts.
Okay. Well, we already kind of talked about it, but I recently updated the JIT builds to use LLVM 19. So for folks that don't know, the LLVM is a build time dependency, not an end user dependency, and we use it to generate stencils that we need for our JIT, which is a copy and patch JIT, which I think Brant probably covered like pretty end to end in his episode or in more depth. But basically, I just finished kind of updating LLVM 19 and then also replacing a hack that we had in the JIT where we would manually patch in the GHCCC or the GHCC convention in LLVM IR before compiling. And so now we're using preserve none instead, which is a feature of Clang 19, which basically doesn't it basically says that the callee is not like preserving the registers, and instead the caller has to like explicitly save and restore them if they care.
Yes.
But basically, we were able to remove a lot of really like hacky code that Brant, in his own words, told me, I am not proud of this. So thank you. So we were able to do that. And I think we got like a very small performance improvement out of it. But so that's now in place. The only platform that doesn't support that new calling convention is like 32-bit Windows. But I might go, if I decide to go and like, I don't know, subject myself to trying to work on LLVM, I could go and maybe contribute that work to their project. We'll see.
Oh, that would be interesting. So upgrading from LLVM 18 to LLVM 19 sounds like, okay, is this more like upgrading a dependency, or is this more like moving from Python 2 to Python 3? So I look at this PR and I see that like this took quite a lot of work to complete, right? Like there's 48 commits on that thing, and there was like 2 weeks of review on this. So this was some delicate work that you put in there. So what took the most of your energy on that?
Well, so there were a couple things that like came up. So I would say that the movement from 16 to 18 was way worse than 18 to 19 because there were like new instructions we had to go and like futz with. In this case, it was like, update the version, and then thankfully a lot of the package managers like Brew got 19 a lot earlier than I got 18. So like a lot of it was like waiting for a lot of like Chocolatey and all the ones that we use in our CI to actually catch up and have 19 available. And then aside from that, like there was some like fold operation that needed like some massaging for like bit masking some of the registers. And then, that it wasn't too bad, but the PR did kind of spiral because at first it was like just do LLVM 19 and then it was like, oh, and also remove this hack.
Right.
So I ended up just kind of, because I was working on both of them in tandem, and so I just kind of rolled them into one PR. So that's probably why it looks like it took a while. It did take a while. I had to it was a lot of trial and error, and then Homebrew had another issue with installing Python that is related to GitHub Actions. So yeah, it was just like a bunch of things to kind of tease apart.
Very cool. Very cool. So now let's talk about the last few weeks in CPython. What's
going on in CPython?
All right, so maybe let's start with a thing that nobody, save for the core developers, will actually see. Well, maybe you will if you contribute to Python, which is that we will now start to enforce reviews on pull requests that are features. It might be surprising that we're doing it so late, but there is a lot of code in Python, and some of that code doesn't really have many concurrent maintainers. So previously, we were really lenient about how we approach reviews. Obviously, we love when there is a lot of review on pull requests, as we already mentioned on the pull request of the week this time. But there was nothing that actually told us to do reviews every time, to enforce reviews. And to be clear, we don't want them on a number of pull requests that are just configuration of CI and so on and so on. And even for bug fixes, most pull requests that you're going to see are actually backports of a pull request that we already had. So those really rarely require heavier review. So we're starting with enforcement of reviews on features alone. And those are changes that I'm making. So that process is already now being enforced. I am a little afraid that I'm going to be this sort of messenger, since that's not a change that I came up with.
Everybody hates Łukasz now because it's bringing the law. It's the
Yeah,
sheriff.
it's something that the steering council wanted me to do, but now since I
it's
did,
Łukasz. It's all Łukasz. No. Don't believe this guy. It's
yeah,
Łukasz.
Łukasz is going to be blamed for whatever happens.
That's your job, man. That's your job. You're the emissary
Yeah,
of the
that's
the
fine
doom.
though. Yeah, like money changes a lot, like how you approach those things. So I don't mind being that person.
It's a fair comparison. I mean, maybe, I don't know how geek is this reference. I hope it's actually translated very well. But it's a fair comparison to say that the steering council is Galactus and you're the Silver Surfer.
I have not heard those names in like years. I haven't heard.
But you pick the reference, right?
Yes.
Like the Silver Surfer is this entity that goes to planets just weeks or before the cosmic entity that is Galactus arrives to the planet just to eat the planet. So you just the emissary.
Yeah.
Okay.
So I'll let you cover those more sort of fun things then. Like let's talk about like new features added to Python.
Awesome. So we have, let's start with this PR by James Roy at Ruang, that's the handle. So this is to add a new function to the C API. It's called pylong is positive, 0 or negative. Like those are actually like three functions. So just it checks if a long object is positive, is 0 or negative. This starts to look like npm, like is even, like that's the like the package. But this is quite important because it provides basically a fast alternative to pylong getSign.
getSign.
Which was proposed by Sergei Storchaka based on basically private existing functions. And this is quite important because like normally like we do have this kind of like fast private APIs inside CPython, but like when extensions need to manipulate or check like long numbers, they normally need to convert these to C intrinsics and like then do the comparisons there, and like there is problems because long objects are unbounded in Python, so like getting these functions in a fast way is very difficult if you need to convert to C. So this exposes these functions in a way that for very common operations. The other one, which is quite important because it completes like a work that we started in 3.13, adding colors everywhere, by Bogdan Romaniuk. Probably you know how to pronounce it better. I hope I'm not butchering the name. But this is basically ensuring that the color, the locations in exception group tracebacks. So this is when you use exception groups and then you have like multiple exceptions and whatnot. So it turns out that those were not really colored just because they follow a different path in the exception mechanism. And that kind of sucks. So we added Bogdan added basically this code. So the exceptions locations are now colored the same way anything else, and it works also on PyRepl as well. This is particularly valuable when you're dealing with code that raises multiple exceptions, obviously, because ensuring that you understand where are the actual errors is quite important, and you have multiple exceptions that becomes even more important.
Yeah, and obviously the consistency is important as well. That it doesn't matter whether you're using simple exceptions or groups. Now they're going to be formatted just as neatly, which looks like it's a first class feature, which it is. So yes, thank you, Bogdan.
Okay, we also have now Tkinter now supports TCL and TK9, which is the I don't know if it's the last version, but certainly it's the modern version.
Yeah, that's the super newest version at this point. Yes,
which is quite cool.
Yeah, that was added by Mark Koller.
Awesome. And we have an mscripten one, which is very close to your heart. So maybe you want to cover this, Łukasz?
Right. So mscripten is one of those two possible futures for CPython running on front-end browsers, right? So not actually being served from a server, but actually Python code running on your Firefox, on your Chrome, and so on. Mscripten is this one that tries to emulate a Unixy platform such that a lot of code that expects files to be there and expects other sort of POSIXy behavior can almost, like, if you squint hard enough, just work fine. There's still going to be things that will not work, like, you cannot start threads and you cannot access any particular real file on disk. Though, then what I'm talking about is a sort of virtual file system that puts files where a Linux-based application, a Unix-based application would expect it, and so on and so on. But that support was mostly needed for external projects, and since there were no maintainers, actually the support for that was removed as a platform in Python 3.13, and PEP 11 was updated saying, support dropped. But it turns out people want it back, and there's interest in maintaining this, which is great. This is fantastic. We got a new contributor. Hud Chedam is a friend of ours. He's a mathematician and the maintainer of Pyodide, who recently became a triager for this. So there's going to be a person actually caring about mscripten because Pyodide is based on mscripten. So we're seeing this platform kind of returning to us. We are more kind of internally interested in WASI as a platform that is, how do I put this? It doesn't try to be Unixy. It's more platform agnostic. It doesn't try to attempt to lie to the program that there is a regular file system and so on. The support for it was a lot of work. Wow. That was in large part Brett Cannon and Christian Heimitz that spearheaded the support. So this is something that we never dropped. That is supported by us, but now mscripten is coming to Python 3.14 again. So rumors about it being dead were premature.
I'm very happy to see who here close to this.
Yeah, me too.
Okay, so now we have a new function in the inspect module. So this is inspect each package by Xiaokang Zhang. And this does what you think it does. It just checks if something is a package or not, which turns to be quite useful for framework developers that are kind of trying to see if objects are packages or not, which is a bit hairy, specifically because the interface can be quite tricky. So that is a nice thing to have when you want to inspect a bunch of different things. Well, you do maybe import hooks or something like that. So quite cool. Then we have also a class get item to memory view, which also enables generic type annotations with memory views, which was the real goal here. And apparently this is obviously for static checking and type checkers.
And finally, we have the best feature, because I didn't know this, but if you have more than one JIT inside one programming language, which Pablo will always tell you, that he was the one.
I was first.
Yes,
I was first.
With the first JIT.
as Justin would like to say, it's technically second, and he was third because C-types has a JIT that we use.
But the C-types JIT is very well behaved. You can have it on because it will do its thing, and nothing breaks. And what about the JIT of Pablo and the JIT of Justin? It turns out, when they fight, everything blows up. You cannot have them used both at the same time.
No. Yep.
So now Pablo Galindo, you might know this guy, added a new feature where we will actually have this situation discovered and prevented. You cannot enable both the big JIT and the perf JIT. Yeah, which is sort of sad for now, I guess. But yeah, it's
well, it's also unclear. There is many ways to have them at the same time. Like you can activate, for instance, the perf JIT at the start, but also dynamically on some random point of the interpreter. So what should happen is unclear. right now what happens is that you try to use perf JIT from the start and you are using the normal JIT, then the normal JIT gets deactivated. But like if you try to activate the perf JIT in the middle, then the perf JIT complains, is like, no, I'm not activating with this other guy, like, looking at me. And honestly, most of this is not like people that have to try to activate both and say like, oh, look, these are not compatible, blah, blah, blah. It's morely tests, because like if you try to run the perf JIT test with the other JIT, then everything goes to shit. So like we needed a way to basically prevent the test from running if both are activated. So which we discovered, by the way, that there is no way to know if the JIT is activated. Do you know that?
There's no way.
There is no way to know if a build has the JIT activated. Like there's nothing, like nothing. So now, yes, there is nothing.
Somebody should add that.
Yeah.
Yes, it turns out that the way to check this was like a poor man way to check this was like checking in configure, like PyConfigure, if the PyJIT flag is in the C flags, right? So
yeah, with get
like,
config vars.
Which is, yes, exactly. But do you know where it doesn't work? On Windows, because there is no such thing as that. So like on Windows, you couldn't know if the JIT was activated or not, which was really painful. So literally, we had to hack around something in the test that is, if Windows, then allow this warning.
Right.
Yes, that's sad. But I think Donghina or Kenjin, I think it's Kenjin maybe. Like he's having like is JIT in the sys module or something, or is JIT active or something like so. So that is being taken into account, but like if there wasn't. And we have a bunch of fixes which are quite important. One of the first ones is in C types, fixed by George Alexopoulos. And this is because like this is a quite common error actually. I'm pretty like happy to see that this is also something that we have in CPython. So it turns out when you open a set object with DL open, that gives you kind of a opaque pointer, a handle representing the DL open object, and then you're supposed to call this other thing called DL sim. So it's a function in libc that basically like you can extract symbols from it. Actually, that is how Python extensions work. When you want to import an extension, let's say it's called foo, the first thing like the Python does is that it's try to find a symbol called py_init_foo in the extension, and that will return a module object, right?
Uh-huh.
Okay, turns out that like DLSim returns like a pointer to the function inside the set object. So if the pointer is null, you will say, okay, that means that it's an error. But no, because like the pointer can be null. Like for instance, you can have a symbol, a global variable called Łukasz, and then you can put null there, and it's fine. Like and then you can return null. It's fine. It's not an error. So there is this other function called DLError, which you're supposed to call twice. First before you call DLSim, just to check that there is not an error before you call, because like obviously if you call it afterwards and it was an error, then you're going to see the previous error. So you call it once. That clears out the error and returns if there was any error before. Then you call DLSim and then you call DLError yet again. So that is something that in C types we were doing wrong, and we were raising if the symbol actually was null. So this is fixed. And then we have a fix by our one and only Gregory Smith in multiprocessing. Actually, this is quite old. I think it's since Python 3.4. So this is in multiprocessing for server, which now currently inherits the parent sys.path. And this is basically the bug could cause some fork servers preloading to silently fail to be preloaded. Basically, this will lead to a performance degradation in the child processes due to additional repeated work that every child needs to do because there is no preloading. So yeah, quite long bug. Fixed by Gregory.
Speaking of friends, there is a fix by Carl Friedrich Bolz, our friendly PyPy maintainer, where it turns out that in some corner cases of importlib, corrupt PYC files were still written to disk. And that could also cause, in the best scenario, to slow things down, since Python would discover that the PYC file was invalid and would have to actually redo the compilation on the fly for that particular given file. So that is now fixed in GH 12.66.27. And finally, we have quite a doozy that it sort of qualifies in multiple areas of the interpreter, which is a fix for a crash if dunder iter raised an exception during yield from.
It's quite interesting that this was not fixed before or it was there. So this bug happens basically if you have a class that implements dunder iter and you raise an exception and then you use yield from with this class. So for instance, you can have a class stupid, and that implements iter, and you just raise whatever, and then you use yield from stupid, and that's an instance of the class stupid, and that was just crashing the interpreter. And in particular, it was crashing the interpreter because the opcode that was basically checking for the yield from is called get yield from iter was incorrectly checking for null inside the return values and whatnot, and before continuing. And that is a fix that was made by Peter Biedma, and it only applies for 3.14.
Cool. Let's move to performance. And let me start with something that is like, I guess, a foundational sort of one of those big moments in a development of a Python version, which is, if you listen to our episodes before, you know that the free-threaded Python is now a sort of work in progress, in the sense that certain optimizations, most importantly, the specializations that the interpreter is doing, are all disabled because they were not thread safe. So now it turns out the foundation for this, which is thread local bytecode, is implemented, and specialization is already enabled for binary op, which is a very popular opcode that a lot of sort of introductions to how Python works internally, including mine, use. So that is already enabled in free-threaded builds. So yay us. This was added by Matt Page, one of the newest additions to our core development team. So I'm very excited to see this.
Awesome.
Changing gears, we have a standard library to handle tar files. And it turned out that it made some single operation so inefficiently that Johan Furberg managed to make it up to 8 times faster for large archives by caching user ID to username mappings. It turned out that this check was made so quickly and it's so slow compared to everything else being done that you can speed things up very drastically. It's very rare to see speed ups of 8 times in Python at this point. So very impressive, Johan, very impressive.
That's fantastic. And then we have another PR by Justin, our friend Justin. And this is basically not in the JIT compiler, like immediately, but like it's related. And this is about the JIT optimizer. And this is basically implementing like a new, like support for a new bytecode, which is basically to add two strings together. The bytecode is called binary op in place add Unicode. It's this tiny PR that just teaches the optimizer about it. And it speeds up those it can speed up those particular instructions.
Wow, very cool.
This is, by the way, this is kind of a interesting thing because, like in CPython, as you know, like technically speaking, like adding a bunch of strings together is quadratic, right? Because like every single time you add two strings, because they are immutable, you need to locate a bigger one. But since like the beginning of time, it was never actually quadratic because you have this weird hack that I think we discussed in previous episodes when we kind of reuse the corpse of one of the strings that you're adding together to just create the other one. So we really don't, like we do the in-place addition. We mutate a string, even if strings are immutable, only in some cases. So at least this kind of like binary op in-place add Unicode, like I think it goes into this direction as well. So I'm pretty happy that even when we keep adding like more complicated machinery, we keep kind of like preserving this kind of hack. So like when the students actually want to check what the teachers say, this is quadratic because the strings are immortal, and they say, well, that's not what I'm saying. So
Right.
like now even faster.
Yeah, and finally, this is more of a, I don't know, internal change, but all of the things that we're talking about are internal. So in Python, we have this thing called argument clinic. This is a code generator where you put some neatly formatted comments in C code, and the Python level argument handling for Python functions is being generated for you, such that it's uniform, such that the handling of keyword arguments, position only arguments, and so on, like always is the same. Before we had Argument Clinic, that was an idea and implementation of Larry Hastings. Having all of this done every time manually caused a lot of grief. There were, rampant incompatibilities by certain C implemented functions in Python. And also, it was really tricky to make this always correct so that you never missed some incref, decref, and so on and so on. So now we have this code generator, And we rely on this increasingly. In fact, only very recently we added support for some members in functools to be using argument clinic automatically, and so on and so on. So Serhii Sturchaka noticed during a lot of his maintenance these days that var positional argument handling was somewhat not perfect. And he made this big issue where he listed all ways in which he was unhappy how that worked, and actually provided a fix which, from your perspective as a user, makes the now generated var positional argument handling more efficient, since there are some micro optimizations that were previously missing and now are possible because of the redesign. And in some cases, there are going to be better error messages if you're trying to do something that Python considers invalid. So very impressive work, because it's sort of some of those things that maybe it's not so flashy as, the JIT or PyREPL. But it is extremely important because we rely on this automation more and more, such that we have correctness and cohesion of how Python behaves, and finding ways to optimize things there, not just in terms of efficiency, but also in terms of clarity of design. Very cool. So thanks for that, Serhii.
Not only that, like this has a stupid amount of impact, because like when you this is not the first time Serhii has been optimizing argument clinic in different ways. I will say that it's probably the 10th time he has done it, and like every single time he has one of these micro optimizations, because we are using this everywhere. Like all functions get the faster, right? Like so that's quite cool, because it's a way to have like a stupid amount of impact, because you're not just making faster functools, you're making faster everything that uses this. Even a tiny bit. So you call it in a loop, then it becomes even much faster.
Agreed.
So that's quite cool.
All right.
Awesome.
So let's talk about security. There's a bunch of fixes that we're going to actually release with 3.12.8 that is going out on December 3rd. One of those things is going to be Benedict Tran hunting use after freeze and out of bounds errors in async IO. So long story short, there is an ability in Python, if you're not careful, if you're writing C code, to actually decref something, to free memory with malloc free, and then continue to hold on to something and read that memory. But it might change. It might change at any given time. You don't own it anymore. We see some of those things when we have debug builds. We talked about this in the previous episode, but if you run a production build, there are no slowdowns that those PyDebug checks introduce. So you might run code that is badly written for a bit and only discover this later. And it turns out async IO itself did have a series of use after freeze and out of bounds. There are 3 PRs about this: 12.59.84, 12.59.66, and 12.59.69. Nice. So they fixed the use after freeze and so on. That's good. This is going to release December 3rd. And also, we have a crash fixed in sysaudit that turned out to be sometimes we have overzealous asserts, and that was one of those where there was an assert introduced in 3.13, so that crash only affects 3.13 and main, which is going to become Python 3.14 in the future. So that is fixed. And there's some CVE fixes that we've done before, so we're not going to be talking about those, but we're going to be releasing them as well on December 3rd.
Awesome.
There were a lot of changes since the last episode until this episode. If we did not cover some change that you consider very important, we're sorry. But also, if it's really foundational in the sense that, hey, Python users should know about this, just let us know. Ping us anywhere that you can find us, and we'll cover it next time. It's impossible for us to cover all changes. There's 18 pages of PRs since the last episode, so the entire episode would.
Maybe we should do episodes more often, and it will be less PRs to talk about.
Yeah, like even every day, that would be stuff to talk about. Yes, but it's not sustainable in terms of actually pulling this off. And I'm also worried the listeners would not appreciate this if we actually released every day. So
it will be the real changelog podcast. It's just reading the changelog in just to go to sleep, right? You know, PR 125985.
Yes, the actual changelog. Yes.
Awesome. So thank you very much for being us here. I hope you have enjoyed this interview with Savannah. How was it?
Horrible.
You're never coming back.
Horrible.
I'm going to spread the word that no one should come on this podcast because they're cyberbullied. And
what if this comment is edited out and it doesn't actually get to anybody?
Cyberbullet and censor. What a combination.
Yeah.
At the same time.
No, it was lovely. It was great. It was great. You both are really fun to chat with and made this pretty easy. And hopefully I did an okay job.
Were you nervous?
I was less nervous once we got started. Hopefully I did an okay job of explaining things.
You did an excellent job. I think it's fine.
Yes, fully agreed. Like the interview section was over an hour long. So clearly good conversation.
Awesome. So thank you very much for being us here. I hope you have enjoyed this interview with Savannah. We were very excited to have her. And until the next time.
See you next time.